Okay, just a few more examples to look through. Here we got a boy on a hill, and he's going to launch a slingshot the water balloon trying to hit his buddy that's straight across from him. So if he launches straight across, I mean, that's his goal, okay? As soon as that water balloon's released, the boy drops. As the boy drops, the water balloon is going to do one of these and hit him, okay? So the second boy thinks he can avoid it. Obviously, he made the wrong move. Because of gravity, the water balloon is going to launch down and hit this boy. Please ignore air resistance, and you can see why that happens. We could even do math with that if we wanted to. Just another equation I wanted to show you. It's the range equation. You take the initial velocity squared, okay? You take this sine of 2 times your angle of launch and then divide it by whatever g is, that whatever planet you're on or wherever you're at. And then this is only good if your y is on a flat surface so that it launches like this. So if your y initial is equal to your y final. Obviously, if you want to find your max range without wind resistance, 45 degrees is the max range. You just take initial velocity squared over g, and that will tell you your max range. Though these aren't on the AP test or on the AP sheet, it's a good equations to use for quick calculations. You could use the others. This is just a quick way to do them. Okay, range of a cannonball. So let's say we have Napoleon's cannon here, and it has a muzzle speed of 60 meters per second. And at what angle should it be aimed? Ignores to strike a target that's that far away. And again, the range equation is going to be VO squared times the sine of 2 theta over g. So we got 60 squared times the sine of 2 times our angle over, and we're going to say we're on Earth, and it's going to equal 320 meters. So we got to do some math here. Got to multiply by g and divide by 60 squared, and take the inverse sine, divide by 2. But in the end, we'll get our angle. And that's how we can solve this problem. Now let's look at here. We're punting a football. So we got to punt it. We're a height 1.0 meters above the ground. How far did the football travel before hitting the ground? Now, here's your, is that you want to make this point here 0. Okay, so we have to set our x0 and our y0. So we're going to put our coordinate system there and make this point y is -1. And we'll kind of show you mathematically why that's the way to go. Okay, but we have information from previous examples with the football. We know our initial velocity in the y from the last was 12 meters per second. Okay, and we know that we want to find our y distance. Okay, so y is equal to initial y plus your y velocity initial plus 1/2 gt squared. We're going to work our way to solve for t. And to solve for t, we know we're at -1. It's going to be our y. Our initial is 0, because we're launching from here to here, right? Our initial velocity, we already said, was 12t, plus, and g being 4.9, it'll be 9.8, take half of that, -4.9 t squared. And you can see right now, if I bring this 1 over, I get a quadratic. So I have -4.9 t squared plus 12t plus 1 equals 0. I use my quadratic equation solver either online or what on your calculator, and I get 2.53 seconds, and I get negative 0.081 seconds. Obviously, you can't have negative time, so our time of flight is going to be 2.53 seconds. Once we know our time, then we can slide right in, and we can use v sub naught x times t, okay, to find our distance. So our initial velocity in the x, again from the previous example, is 16, multiplied by my time of 2.53 seconds, and then my x will turn out to be 40.5 meters. So that's how far it went. But you can see when I make this, when I start below and I go hit the ground, I can use this to use initial and final distances to solve my problem.